Graphing transformations, part 2. We have a formula. A is for amplitude, B is for the period, C is for the phase shift, and D is the vertical shift. The function that we're working with is y equals sine of theta divided by 2 plus 1. My amplitude is 1. My period, I cannot see too clearly here. Y equals theta divided by 2. There is a 1 in front of the theta. That's 1/2. I would like to rewrite sine theta over 2 plus 1 as y equals sine 1/2 theta plus 1. My period, I need B. Our formula for period is 2 pi divided by B. That means that we have 2 pi divided by 1/2. Some people will make the mistake of putting 2. It's 1/2. We can also use, instead of 2 pi, we can use 360. This time I'm going to use 360 divided by B, which is 1/2. How do we divide fractions? We flip and multiply. That becomes 360 times 2 over 1, which equals 720. Our period is 720. Half of 720 is 360. Half of 360 is 180. We are moving in increments of 180 degrees. 360 plus 180 is 540 degrees. The next thing I would like to look at is the vertical shift. The vertical shift, D, this function is being shifted up 1 unit. So here's the origin. We are shifting up 1 unit. My amplitude is fluctuating by 1. My amp is 1, so that means 1 above and 1 below. We'll be up at 2 and down to 0. The angles that we're using are 0 degrees, 180, 360, 540, 720. Y equals sine 1/2 times 0 plus 1. 1/2 times 0 is 0. Sine at 0 degrees. Sine at 0 degrees is 0. And 0 plus 1 equals 1. At 0 degrees, sine is 1. A half times 180 is 90. We're looking for sine of 90 degrees plus 1. Sine at 90 degrees is 1. And 1 plus 1 is 2. At 180 degrees, sine is 2. We're starting to see the pattern here. One half times 360 is 180. Sine at 180 degrees is 0. And 0 plus 1 is 1. 1, 2, 1. Can you predict what the next number is going to be? Sine at 360 is 1. We're already starting to see the pattern here. We are on the line, above the line, on the line, below the line, on the line. And I can continue that pattern over here. And there is our function. The next function that we are going to graph is y equals cosine theta minus pi over 4 minus 2. We see that our amplitude is 1. We have a vertical shift down to -2. Next, we're going to look for period. Period, if we look in front of theta for b, we see that theta is 1. Our period is 2 pi divided by 1, which is 2 pi, or 360 degrees. We are going in increments of 90 degrees, 180, 270. Our amplitude is 1, so we want to be 1 below here. Okay. The angles that we're using is 0, 90, 180, 270, and 360. We are starting with y equals cosine theta. We're going to do the phase shift last. So we're going to look at cosine theta minus 2. Cosine at 0 degrees. Cosine at 0 degrees is 1, and 1 minus 2 equals -1. At 0 degrees, cosine is -1. Cosine 90 degrees is 0. 0 minus 2 is -2. At 90 degrees, we are at -2. Cosine of 180 degrees is -1. -1, -2 equals -3. At 180 degrees, we are -3. I can already see the pattern. Here's the axis that we're using here at -2. So we are above, on, below, on, above, and continuing, we're above, we are on, we are below, we are on, we're above, and we draw the function. Now I am ready for the phase shift. The phase shift, we are shifting this over pi over 4, a quarter of a pi. That would be 45 degrees. A quarter of a pi is 45 degrees. Here's 90. Here I'm going to take this point and I'm going to shift it to the right 45 degrees. I'm going to take this point and I am going to shift it 45 degrees to the right. When it says minus 45 degrees, that means we are shifting it 45 degrees to the right. I will be shifting all of these over 45 degrees. So 0 plus 45 is 45, 90 plus 45 is 135, and so on. I am just shifting all of these points over a half. And shifting on this side, I will be shifting over 1/4. And now I can see that my function has a phase shift of 1/4. It has been shifted to the right 45 degrees. Let's talk about the domain and range. The domain of this function would be all the reals. And the range of this function is fluctuating between -1 and -3. So the range would go from -3 to -1.